What if I told you that the universe might contain cosmic objects that are the exact opposite of black holes, regions of space that nothing can enter, but from which matter and energy can escape? Hello and welcome to the Cosmic Horizons podcast, where we explore the most fascinating mysteries of our universe. Today, we're going to take a closer look at one of the most mind-bending theoretical ideas in physics: white holes. Now, I know what you're thinking. White holes sounds like something from a science fiction novel, doesn't it? But these bizarre cosmic objects have a legitimate place in theoretical physics, and they might just change how we think about the universe. So grab a cuppa, get comfortable, and let's dive into this fascinating cosmic mystery together. When most of us think about extreme objects in space, black holes immediately come to mind. These cosmic monsters have captured our imagination for decades, regions of space where gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. They're like cosmic vacuum cleaners pulling in everything around them. But what if I told you that the mathematics of Einstein's general relativity, the same equations that predict black holes, also predict their opposite? Enter white holes. Theoretical objects that nothing can enter, but from which matter and energy can escape. They're essentially black holes running in reverse. Now, I should be clear straight away, no one has ever observed a white hole. They remain entirely theoretical, but the maths behind them is rather compelling, and they might help solve some of the most perplexing puzzles in modern physics. To understand white holes, we need to think about time reversal. Imagine watching a video of a black hole in action, with matter spiraling inward and disappearing beyond the event horizon. Now imagine playing that video backwards. What you'd see is matter emerging from a central point and spreading outward. That's essentially what a white hole would look like. It's a bit like watching raindrops falling into a puddle and then seeing the film reversed, with droplets leaping up from the surface. In our everyday experience, we know which direction makes physical sense. But at the cosmic scale, with the strange mathematics of general relativity, both directions can be valid solutions to Einstein's equations. The concept becomes even more fascinating when we consider what happens inside black holes. According to classical general relativity, at the center of a black hole lies a singularity, a point of infinite density where the laws of physics as we know them break down. It's a cosmic dead end, if you will. But some physicists have proposed that this might not be the whole story. In March 2025, researchers published a groundbreaking paper suggesting that black holes might eventually transition into white holes. They used a simplified model called a planar black hole and found that the singularity at its center could represent not an ending, but a new beginning. A point where matter and energy, and perhaps even time itself, could be ejected back into the universe. This idea connects to a broader theory called loop quantum gravity, which attempts to merge general relativity with quantum mechanics. According to some versions of this theory, when matter collapses into a black hole and approaches the singularity, quantum effects might cause it to bounce and transform into a white hole. It's rather like a cosmic trampoline effect. I find this absolutely fascinating because it challenges our intuitive understanding of time's arrow. We're accustomed to thinking of time as flowing in one direction, from past to future. But these theories suggest that in the extreme conditions near a singularity, time might behave very differently indeed. Now you might be wondering, if white holes are the time reversal of black holes, and we know black holes form when stars collapse, then how would white holes form? And that's where things get properly mind-bending. Some theorists suggest that white holes might have existed since the beginning of the universe, or they might represent the other side of black holes in our universe, or even in another universe altogether. One particularly intriguing idea is that our entire universe might have emerged from a white hole. The Big Bang shares some characteristics with how we might imagine a white hole, matter and energy erupting from a singularity. It's a speculative idea, to be sure, but it illustrates how these theoretical objects might help us understand fundamental questions about cosmic origins. But if white holes might exist, why haven't we spotted one yet? Well, there are several challenges. First, if they're the time reversal of black holes, they might be incredibly rare or short-lived. Some calculations suggest that a white hole would be unstable and would collapse almost immediately upon formation. Second, how would we distinguish a white hole from other energetic cosmic events? Some researchers have suggested that certain gamma-ray bursts, incredibly powerful explosions detected from distant galaxies, might be white hole signatures. But these could also be explained by more conventional astrophysics, like neutron star mergers or supernovae. There's also the matter of cosmic censorship, the idea that singularities are always hidden behind event horizons. If white holes exist and eject matter from their singularities, they might violate this principle, which makes some physicists skeptical about their existence. Despite these challenges, the concept of white holes continues to fascinate researchers because they might help resolve some thorny problems in physics. For instance, they could address the black hole information paradox, the question of what happens to information that falls into a black hole. If black holes eventually transform into white holes, perhaps that information isn't lost after all, but is instead preserved and eventually released back into the universe. So here's the big question that keeps me up at night. If white holes are the time reversal of black holes, could they represent not an ending but a new beginning? Could matter falling into black holes in our universe be ejected as white holes in another universe or another time? And what would this mean for our understanding of cosmic cycles and the fundamental arrow of time? These questions touch on the very nature of reality. They challenge us to think beyond our everyday experience and consider possibilities that seem, at first glance, utterly bizarre. But that's what I love about theoretical physics. It pushes the boundaries of what we think is possible. Looking to the future, several developments might help us determine whether white holes are merely mathematical curiosities or actual physical objects. Advanced gravitational wave detectors like the upgraded LIGO or the space-based LISA mission might detect signatures that could distinguish white holes from black holes. Theoretical physicists continue to refine models of white holes using increasingly sophisticated mathematics and computer simulations. The ongoing quest for a theory of quantum gravity, which would unite general relativity with quantum mechanics, might provide new insights into whether and how white holes could form. Some researchers are also exploring connections between white holes and other cosmic phenomena, like dark energy or the expansion of the universe. Could these mysterious forces be related to white hole dynamics on a cosmic scale? It's early days, but these questions show how theoretical concepts can lead to new ways of understanding our universe. Well, that's all for today's cosmic exploration. I hope you've enjoyed our journey into one of the universe's most speculative frontiers. If these mind-bending ideas have sparked your curiosity, do subscribe to the Cosmic Horizons YouTube channel for more cosmic mysteries and fascinating science. I'd love to hear your thoughts on white holes or suggestions for future topics. Drop them in the comments below. And remember, in a universe as vast and strange as ours, even the most outlandish theories might contain kernels of truth. Thanks for joining me today. Until next time, keep looking up. The universe is stranger and more wonderful than we can imagine.